Okay, so here's the third part of this particular paper. It's January 2007 and it's the completion paper for the foundation tier, MF or N5, and it's paper 2. And we're now going to move on to question 11. So you have a look at that and stop the video and then we'll go through it in a minute. Okay, so here's question 11. Here we're told rather the surface area of a cube is 486 centimeters squared. So there's a cube, you can imagine a dice shape. It's got 6 faces, and this is telling us that the area of all those 6 surfaces is 486 centimeters squared, and it wants us to calculate the length of the edge of the cube. So that's one of the edges here. So any of these edges you can imagine, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges altogether, and they want us to calculate the length of one of them. So we're given that the area of all 6 faces is 486 centimeters squared. So in other words, the area of one face is going to be 1/6 of that. So it's 486 divided by 6 is 81 centimeters squared. So now we know now that one face, take this front face here, that face there has an area of 81 centimeters squared, and what they want us to find out is what's the length of one of those edges. So it's this length multiplied by this length must equal 81 centimeters squared, and the way we find that is we take the square root of 81, and this is a calculator paper, so you can key that into your calculator, and the answer then is 9 centimeters. Okay, there's question 12. Just have a look at that and we'll go through it in a few seconds. Okay, so for question 12, it's telling us in the table here there's 5 possible scores in an arcade game, and we're given the probabilities of 4 of them, and we have to complete the table to find the probability of getting a 10. So in these ones we have to remember that all the probabilities must add up to 1. So we can add up these 4 probabilities here: 0.35 plus 0.25 plus 0.15 plus 0.1 gives us 0.85. So the missing probability in here must be 1 take away 0.85. That's what those 4 there added up to. So our answer there is 0.15. That's the missing probability of scoring a 10. Part B then says, in a single shot, what's the probability that he scores at least 10? So you need to remember here that at least 10 means it's 10 or more. So the 3 possible scores you could get are 10, 20 and 25. So what are the probabilities of those? We've got probability of a 10 is 0.15. We've just worked it out in part A. Probability of scoring a 20 is also 0.15. Probability of scoring a 25 is 0.1. So we add those together and the answer then is 0.4. Okay, the last part of the question then is a player takes 60 shots. How many times would you expect this player to score exactly 5? So the way to think about this is if a player takes 1 shot, the probability here in the table is telling us that the probability of getting a 5 is 0.25. So if he's going to take 60 shots, which is what we're told here, then the probability is going to be 0.25 multiplied by 60. You can use your calculator for that, and the answer is 15. So you would expect then to get a 5 15 times. So 15 times out of his 60 shots, you would expect to get a 5, and that makes sense because 15 out of 60 is a quarter, or 0.25 rather. Okay, so there's question 13. If you want to stop the video and have a go at that, we'll go through it in a few seconds. Okay, so for question 13, here we're asked to multiply two powers. So it's g to the power of 7 multiply g to the power of 3. And now there's a rule for this. If you know the rule, then you can just apply the rule. The rule says when you're multiplying letters or numbers to powers, you can add the powers. So g to the 7th multiplied by g to the power of 3 is g to the power of 7 plus 3. So you add the two power numbers. So the answer there would be g to the power of 10. And if you want, you can think of that g to the power of 7 is really 7 g's multiplied together. This little power number 7 tells you how many g's are multiplied together. So g to the power of 3 is telling you you've got 3 g's multiplied together. So that's the same as 7 g's multiplied together multiplied by another 3 g's multiplied together, and that's the same as g to the power of 10. So it's the same answer, but it's another way of looking at the problem. This one, 13b, this time we've got a to the power of 4 multiplied by a to the power of 3 divided by a. Again, there's a rule here, sort of the same rule as before, which we used up there. A to the power of 4 multiplied by a to the power of 3. That's the rule that says for multiplying the powers, we're going to add those two power numbers together. So that becomes a to the power of 7 divided by a. And again, there's another rule that says when you've got powers, you're dividing numbers to the power, then you're going to subtract the power numbers. So in this case, this is going to be a to the power of 7 minus 1, because this is a to the power of 1 here. So the answer is a to the power of 6. Again, you can think of a to the power of 4 as 4 a's multiplied together, multiplied by a to the power of 3 is 3 a's multiplied together. So again, that's a to the power of 7, and we're dividing by an a in the bottom. You can cancel an a in the top, and along with this a in the bottom, and we end up with a to the power of 6. Okay, so there's the last question in the paper, is question 14. If you want to stop the video and have a go at that, we'll go through it in a few seconds. Okay, so for question 14, then we've got a problem here. We're given, this is some sort of a shape, frame of a children's play tunnel. It tells us the cross section. That's this shape at the front of this overall shape is a trapezium. A circular hole of radius 30 centimeters goes through the middle of the whole shape, and we're asked to calculate the volume of the shape after we've cut out this circular hole all the way through. First thing you need to remember here is that you're given the formulas for both of these shapes that you need in the formula sheet at the front of the paper. So if you look at any of the papers, you're given the formula for the area of a trapezium shape. Here we have it, so it's half. You add together the two parallel sides, A and B. You take half of that, and then you multiply that answer by this perpendicular distance between them. And the second formula you need, the volume of a prism, is this area it's called the cross section, the area at the front of the shape, multiplied by the length. So if we go back to our problem here, question 12, so you can refer to your formula at the front, and the formula for the area of a trapezium. Then we've got our trapezium shape. This is this front of the tunnel, clay tunnel. This distance here is 80. This distance here is 55. Those are the two parallel sides. So we add those together, 55 plus 80. We're going to take a half of that, and we're going to multiply that answer by this perpendicular distance between the two parallel sides, which is 65. So again, this is a calculator. You can do what's in the brackets first. 55 plus 80 is 135. We're going to take a half of that and we're going to multiply by 65 and we get our answer 4387.5 centimeters squared. So keep that in that level of detail at the minute. Don't round that answer at the moment, because the next thing we need to do is, it told us that there was a circular hole that was cut out of the trapezium shape. We know the radius of that circle, so we're going to find out what the area of this circular shape. So we've cut this circular out of the middle of this trapezium shape. So the area of a circle, which is a formula you have to remember, is pi times radius squared, pi r squared. So we know the radius is 30, so it's going to be pi multiplied by 30 squared. Again, you have a pi key on your calculator, so you don't need to calculate that, you don't need to know that. So if you press pi multiplied by 30 times 30, or 30 squared, you get 2827.433 centimeters squared. So that circular bit has been cut out, so we need to take away that from the area of the trapezium shape that we worked out a few minutes ago. So it's 4387.5, take away 2827.433, and we get this remaining area, which is this shaded or hatched area round the outside of the circle, 1560.066. And now we've worked out the area of it's like the area of the cross section. Now we're ready to find the volume. Again, our formula on the formula sheet said it's the cross sectional area, that's this hatched area here, multiplied by the length of the play frame. And if you refer back, the length of the play frame was 150 centimeters. So all we have to do now is multiply the answer we got a few minutes ago, 1560.066, multiplied by the length is 150. Put that into our calculator and we get 234,009.9 centimeter cubed now, because it's a volume we've worked out. And remember, it asks you to put that to an appropriate degree of accuracy. So in this case, most of the numbers in the question are to two significant figures, so we could give that to 230,000 or 234,000 centimeter cubed.